This is Denver Housing's Housing Management's Division's maintenance training for the recently installed solar panels. We're going to be reviewing the basics of grid-connected solar and reviewing safety, operations, maintenance, and other procedures.
So thank you guys for coming today. The purpose of this training is to get you guys comfortable with the solar projects that we've been doing all over the city so far. Get a chance for you guys to ask questions, sort of explain how it works, explain who owns what, and just sort of talk about how you should be interacting with it in the future. So just to start off with, my name is Ryan Delaney. I'm from Namaste Solar. I'm the project manager for all the solar installations so far. With us today also is Jordan Schechter from a company called Infinity. Then we've got Dan and Chris also. And so the way this project works is it's financed through what's called a power purchase agreement, or you'll oftentimes hear it referred to as a PPA. And the way that works is Infinity is the company that owns all this equipment. They're paying Namaste Solar to design and install it, and then they sell the power to DHA over a period of 20 years. So whenever you guys are looking at this equipment, it's important to note that this doesn't necessarily belong to DHA. And there's a couple of things we'd like you guys to do with the equipment over time, but you're not going to be responsible for maintaining it and things like that. Infinity and Namaste Solar have a contract in place, an operations and maintenance contract in place, where we'll come out and perform service on this equipment should it need it. So just right off the bat, you guys aren't going to be expected to get into this stuff or deal with it very much at all. One of the most common questions you guys are going to get from your residents is, how does the solar work? Is this free electricity? How come I get it but somebody else doesn't? How come they get it but I don't? And the trick to how this all works is that right now, since DHA pays a portion of each resident's energy bill, they buy all that from Xcel Energy. And all we're doing is we're setting Infinity up as a little mini power company. So now Infinity is going to sell power to DHA, and then whatever else the unit needs above and beyond what's produced, DHA will buy from Xcel Energy. Typically, Infinity is going to charge less per kilowatt hour than Xcel does. So right off the bat, it's a chance for DHA to lower its operating expenses and save money from the beginning. Nobody really knows what's going to happen with Xcel Energy's rates over the next 20 years, but for every kilowatt hour that's produced through the solar project, DHA knows how much that's going to cost, how much Infinity is going to charge them for it. So when the residents ask, you know, what does this all mean? Basically, the residents themselves aren't going to see any significant reduction in their utility bills, but it's going to help, again, DHA lower that cost of what they pay for the electricity, that they can then do more maintenance, do more buildings, things like that, do more projects. So far, those have been the pretty common questions we've been hearing from residents. So now I just want to talk a little bit about how solar works and how these systems are designed. So everybody's real familiar with the solar panels they see up on the roof. The solar panels produce DC electricity, direct current electricity. That's then piped off the roof to a DC disconnect, which then goes into an inverter. The inverter takes the DC electricity and creates AC electricity out of that, which is consumed on site. As soon as we leave the inverter, we go through an AC disconnect. This little piece of equipment is really important, and we'll get into what that does and how you should be interacting with it. There's also a PV production meter. This meter just registers the total amount of kilowatt hours that this system has produced since we turned it on. So it's always going to be accumulating. It always goes up and up and up and up. Once we leave the PV production meter, we're tying into the main disconnect for the unit. Now, there's different styles of the way we interact with the existing electrical system on different buildings throughout the city. So, for example, Quig Newton, all the units at Quig Newton have a very specific type of electrical service. North Lincoln has a different type of electrical service. Columbine Homes has a different type of electrical service. So depending on what we see at a given development determines how we interact with that system. So that's the reason we're doing these trainings with each of you guys at each different development, because there's some slight nuanced differences between them. Most of what's happening at the dispersed housing stock is called a supply side tap. So in that situation, we're actually tapping onto the service conductors that feed the unit above the main breaker. And that's going to impact how I want you guys to interact with the system. So one of the things that it's important to know about this box is there's a lot of information that it will tell you at any given time. If you walk up to it, it'll be cycling through different screens. You guys don't really need to know anything about that. The most important thing that I want to get you guys comfortable with is a day like today, sort of earlier in the morning, but the sun's out, it's not too cloudy, it's mid-morning. Right now, it may be difficult to see, but the inverter is producing power. And the way it lets you know that it's producing power is the green light is illuminated. It's not blinking, it's solidly on green. That means the inverter is happy. There's two different main types of inverters you guys may see. There's this, which is called an Aurora Power 1. And there's also a box that has a big red cover, and that's an SMA. Functionally, they're the same piece of equipment, they just look a little different. It's from two different manufacturers. Hopefully what we're gonna be training you guys to do as the eyes and the ears and the boots on the ground is be able to identify if there's something wrong with the system. So if you're on site doing your routine maintenance walk, or maybe replacing a breaker or replacing an outlet or fixing a window, we hope you guys can walk by this and take into account what time of day it is and what time of year it is and determine if there's something wrong with the system. There's a couple really basic things that could potentially be affecting how the system is performing that I'm going to train you guys how to fix. So the first most important thing is walking up, seeing the green light is on, sun's out, everything's fine. Let me talk a little bit about how the inverter functions. So these grid interactive inverters are different than the way most people perceive solar. So when most people hear about solar, they think of an off-grid cabin with a battery backup, and if the power goes out, I still get to turn my lights on. That's not how these systems are designed. So there's no battery backup, there's no autonomy with these boxes. Basically, when the grid voltage goes away, for example, if the transformer that feeds this neighborhood blows up, the inverter will immediately notice it. The inverter needs the grid voltage in order to function. So if it loses the grid voltage for any reason, it turns itself off. It basically slams the door between the DC and the AC side of the box. And that's a very specific reason it does that. So if we had a bunch of solar projects in the area and a transformer blew and Excel sent a lineman out to work on it, and he didn't know there was solar in the area, he would potentially be exposed to backfed electricity. And so the reason these are designed that way is to avoid that situation. Now that specific design feature is actually critical to how you guys are going to be interacting with it. So again, AC disconnect, DC disconnect. There's a dial on the bottom of the inverter called that isolates this box from everything up on the roof. So the DC disconnect and the AC disconnect are in place. If we need to, we can come out and remove this upper piece of this equipment to service it or replace it if necessary. So that's why the two disconnects are there. So one of the most easily problematic issues with these systems is that anybody can come by at any time and turn that AC disconnect off. What I've just done effectively is simulate a power outage to the building. So the inverter lost contact with the grid voltage as soon as I hit that AC disconnect, and you guys heard what happened, it immediately turned off. So it's probably not as big of a deal here in the dispersed areas, but a place like Quig Newton, a place like North Lincoln when there's lots of kids running around, this is the sort of situation you may walk up on this site to do, again, whatever routine maintenance, and somebody may have turned this AC disconnect off. So the first thing you'll notice is now instead of being solidly green, the power light is blinking green. There's also an alarm, the yellow alarm light is illuminated, and there is an error code that says missing grid. So as soon as the inverter loses the grid voltage for whatever reason, transformer blows, the whole grid goes down, or the AC disconnect is flipped, it notices that, it slams the door shut. So there's no electricity coming from the DC side to the AC side. So what then happens is the inverter just turns itself off and it won't turn itself back on until the grid voltage comes back on. So this is a very common situation you guys may see. So the easiest thing to do at that point is turn the AC disconnect back on. You hear it click. The inverter will then go through a 3 to 5 minute startup phase where it senses the grid voltage, it senses the grid frequency, and it makes sure everything is legit before it starts producing power. That typically takes 3 to 5 minutes. The Power 1s actually go a little bit quicker than that. So while that's starting up, I want to stop and see if you guys have any questions real quick. I've been sort of talking for a lot.
Call you guys, let them know every time somebody pulls that lever down?
So the question was, if you guys come on site and you see that the lever is off, do you need to call someone every time? And the answer to that is really no. What we're hoping you guys do is turn it back on. The idea is that it's in everyone's best interest, DHA's best interest, the residents' best interest, and Infinity, our partner's best interest, to have these things in operation as much as possible. So we want you guys to feel confident and comfortable flipping that switch back on. Now, it would be great if you would let your maintenance supervisor know, and then he would let Dan and Chris know, who would then let Infinity know. It's great for Infinity to know if these systems have been off, because they'll be monitoring the production each month. They get the bills from Excel, and if they have a system that's been down, it's good to know that you came on site and turned it off. Now, we don't know how long it's been off for at that point, but it's good to know either way. So we would love it if you guys would let folks know when that happens. The other side of that is that if we notice or if it's noticed over time that this particular system, let's say, is continually off, every time you come back to site, it's off all the time, that's when we're going to probably want DHA to step in and have a conversation with the resident about why it's important these things are still in service. So contractually, DHA is obligated to Infinity to keep these things in service all year long, with the exception of 2 days for routine maintenance and things like that. So if you guys notice it, please turn them back on and please tell your supervisor. The nice thing to know about this particular inverter is there are some buttons along here that can affect the readout. That won't damage the inverter at all. It's okay. It just determines how the inverter reads itself out. So another common situation, another thing that a kid could grab a hold of, and especially, they put it under here to try and hide it a little bit, but the problem is it's right at eye level for a little kid, is to turn the DC disconnect off. So when the DC disconnect is off, the inverter will notice that as well and turn itself off. Now, the way the inverter looks when the DC disconnect is off can be a little confusing sometimes, because what I've essentially just told the inverter is that there's no DC power coming from the roof. I've isolated the inverter from the DC power. That same situation exists every single day. When the sun goes down, the solar stops producing. The inverter recognizes that, and then to save power, it just turns itself off. In the morning, when the sun comes back up, the DC power starts being created on the roof, and the inverter will notice it and kick itself on. So if you guys are here at, say, 7:30 in the morning in February, the inverter may look off because it might not be light enough outside to kick it on. So keep that in mind as well. It's important to note that changing site conditions will affect what an inverter is up to. The other side of it is that now the inverter screen has gone blank because I disconnected. I basically just told the inverter it's night. So now I'm going to tell the inverter again that it's morning. It'll go through that same startup phase where it reads everything on the DC and the AC side before it starts creating electricity. So that's another thing that you guys may need to do. Yes. On the boxes that have the red cover lid, is there the same DC disconnect and AC disconnect? On the red ones, there's actually a dial right here instead of underneath. And there's always an AC disconnect right next to these boxes. So the interesting thing is, depending on how we interconnect at the house, whether it's a backfed breaker or a supply side tap or a line side tap, these two pieces of equipment are always right here. So that's the most critical thing. They're always there. So now you can hear it clicking and starting up again. In some cases where in this unit in particular, there's an exterior main disconnect. In a lot of the houses in the dispersed areas, there's no main exterior disconnect. There's just a meter that then feeds into a split bus panel. It's usually in the kitchen. So we're actually interconnecting inside, and we have a box just like this that's inside as well. That's in addition to this box. This box will still always be here. So the trick is, the thing I'd like to talk about next is, now that we've sort of talked about how solar works in general, there's no battery backup, it only works when the sun's out, it turns off when the sun goes down. I want to talk to you guys about, and we've also covered sort of how you could potentially fix the system if you walk up on site. That is the extent of how I'd like you guys to interact with these systems. If the switches are off, turn them back on. That's it. Let's talk a little bit about how you guys are going to be affected by this system if you guys are on site doing routine maintenance. So it sounds to me, in talking to folks so far, that the major work you guys are doing from an electrical perspective may be changing out a breaker, replacing a light fixture, or really that's about it. Do you guys do any more electrical work? Outlets, exactly, outlets and switches. Other than that, it sounds like Shad, the master electrician, is going to be dealing, if we need to replace the main disconnect, that's going to be Shad, not you guys. So the first thing I want to tell you is, whether there's solar on site or not, if you're working in a panel at a unit and you're replacing a breaker, it's best practice to de-energize that panel completely. So turn the main breaker off. Okay, that should be standard operating procedure anytime you're doing electrical work. You don't want to work in a hot panel. Lots of people are comfortable doing it, but if you start at that point, the solar starts to be a lot less scary. So again, as I told you, the main way to turn our system off is through this AC disconnect. So if I were to go, looks like we have a main breaker here outside and there's a load center inside. If I needed to replace a breaker in that panel, I would walk up to this, turn this off. I'd walk to the main breaker, turn that off, go inside and do my work. In that situation, you are completely isolated from the solar. There's no impact that the solar can have. In some cases, we interconnect into a unit through a backfed breaker. In that situation, if you turn off the main disconnect, the inverter will turn off regardless. This thing doesn't matter. However, it's best practice in this situation, if I were to turn that main breaker off right now, without turning this off, the inverter is still live. You'll still be protected if you're working in the panel because the protection is the main breaker. But in this case, we're interconnected into the existing electrical system above the main breaker in that box, so it stays live. Best practice, whenever you walk on site to do any electrical work, go ahead, turn both the AC and the DC disconnect off on the solar, turn the main breaker off for the unit, and you are isolated from any electrical.
Now, is that as far as changing your outlets and switches also?
The question was whether or not you should follow that same procedure if you're changing lights and outlets as well. I would consider that best practice, yes. You should turn off the main breaker for the unit, turn off the solar. Once you're done, remember to turn the main breaker for the power back on, turn the solar back on, and walk away. If I'm just working on one circuit in a bedroom, say a lighting circuit in a bedroom, and I've already turned that breaker off and I'm replacing the outlet, chances are good you'd be safe in that situation. I would say best practice, if you get in the mindset of any time you're doing anything electrically in this unit, turn the main power off as well as turn the solar off. It'll only be down for a short amount of time. Replacing a receptacle or a light socket isn't a huge amount of work. You obviously want to communicate that to the resident, but that's a safety issue that if I were doing it, that's how I would do it. Belts and suspenders sort of safety sort of thing.
And then when turning it back on, just make sure it comes back.
Exactly.
You get your screen and your light.
Exactly. So turning it back on, it doesn't matter which disconnect you turn on first, as long as you turn them both on. The inverter goes through that startup phase. So the nice thing about this is sort of inherent in that. Let's say the power goes out to the building for some other reason. Say this tree falls on the overheads. As soon as that power is restored, the inverter will sense that and turn itself back on. So you guys don't have to go around and reset these things every time there's a power outage. They basically take care of themselves. If they're happy, they're happy. If they're not happy, they turn off until they get happy. So that's basically probably the extent to which you'll be interacting with it. Some other common questions are, if I'm up on the roof doing gutter cleaning or maybe patching a hole or whatever, if I touch the panels, are they gonna hurt me? It's important to note that solar panels, when they're in the sun, are always live. So when I hit this DC disconnect, I'm isolating this box from the roof, but I'm not turning the roof off. So the panels themselves, they're not live as in energized if you touch them, but they're always generating electricity. So if you were to get up on the roof to do routine maintenance, the first thing I would do is walk up to the inverter and see if it's operating normally. If the green light is on, that means there's no fault conditions, there's no chance of getting shocked. If I was going to be working up around those panels, I would also turn the system off, go up there and do my work. Don't be afraid of bumping into the panels. Try to avoid that if you can help it, but they're not going to hurt you. If you walk up to clean gutters and you walk up to this inverter and there's some sort of alarm light illuminated, first thing I would do is turn it off, and the second thing I would do is call your supervisor and schedule that routine maintenance for a later time after Namaste Solar's had a chance to come out and service it. So it's important to, just like when you do a general site analysis when you walk on site, this is just one more thing we're going to have you guys do is look at it. If the green light is on and it's operating normally, you're in good shape. Other things that you may notice, these are other common questions, are that these solar panels are glass. They're made of tempered glass, just like your car windshield. They're tested for durability by shooting a 1-inch ball of hail at them at 50 miles an hour. So they're extremely durable. More often than not, when there's a hailstorm, the roof around my panels gets totaled out by the insurance company, and somebody pays me to come take my stuff off so they can replace the roof and then put them back on. That being said, they will crack. If you hit them with a rock or you hit them with a baseball bat or even a large enough piece of hail, they will break. They break like a car windshield does. It doesn't break into shards. It breaks into little chunks. That's the sort of thing, if you notice that, immediately walk over, turn it off, call your maintenance supervisor, he'll call Infinity and they'll pay us to come out and take a look at it. I would say if you walk up on it and the green light is blinking, the first thing I would do is verify that it's on and make sure both switches are on. If they're on and there's some sort of error code illuminated, I would jot down what the error code is. They're not always, they don't always make sense. They refer to some error code in the manual, but I'd jot that down, turn it off, and then communicate upstream. So that should be sort of the process you go through, is make sure the switches are on, first of all, and then jot down the error code, and then turn it off for safety, and then let everybody know. And usually we're going to dispatch to site within 24 or 48 hours, so you guys don't have to worry that we're gonna drag our feet in getting out here. We like to get out as quickly as possible. So broken module, that's a big deal. We need to know about that. One of the other things that we're asking you guys to do for us is all of this work is covered under Namaste Solar's warranty. So we don't expect you guys necessarily to fix things. So for example, we've done, the overall project is 2.5 megawatts. There's 668 individual systems. Our process is we do the installation, we get an inspection from the city, and then we actually have our own QA/QC guy come back and look at every single system. And he's looking for, making sure the conduits are supported, making sure we got covers on our LBs. All those things are things we're trying to catch. The reality is at that volume, there's probably some couplers they're gonna pull apart, things like that. We want you guys to, if you don't mind, don't feel obligated to fix that if you see it. That's covered under our warranty, but we need to know that it's the case, and we'll come out and do that. So that's another case where you communicate that to Dick. Say, hey, I was on site, and whatever, it looks like they missed a couple straps or something like that. We're happy to come back and replace that. We want to make sure these things are as properly installed as possible. There's different types of graffiti, right? There's graffiti which looks bad, and there's graffiti which is going to impact your ability to work on this or understand how this is working. So if somebody comes and tags this box, it's probably something worth noting and worth trying to clean off. I think DHA would probably prefer to maintain graffiti-free walls. That's not the sort of thing that we need to dispatch for. It's not a service issue. It's not affecting the way the system operates. If you come up and somebody spray painted over this screen, that definitely needs to be replaced. If you come up and somebody spray painted over this, that's something that we need to know about. So there's a little bit of a difference between aesthetic concerns and actually damaging the way the equipment operates. So use your best judgment on that. I mean, if they just cake this thing with spray paint, these are outdoor rated boxes. They've got seals on all the openings. They're made to live outside in the weather. Probably spray paint isn't going to hurt them too much, but if they really get after it, we may want to replace this box. We 100% don't care if you clean this off, if it takes some of the branding off of there, that's just fine with us. Again, I mean, these things they're made to live outside. You're probably not going to hurt them by cleaning them. I would probably shy away from, oftentimes folks use like gasoline and turpentine to clean that stuff off. I'd probably avoid doing that, but typical soap and water isn't going to hurt this box. These serial numbers are taped. We've got various safety stickers on there as well. So if somebody paints over one of our safety stickers, I think that would be, if somebody just tags their initials on here, it's not a big deal. If somebody paints over any of the safety information, we'd probably want to know about that, so at the very least we can replace those safety placarding and stickers. If they take a magic marker to this thing and they tag it with their initials, it's not even gonna, it doesn't matter at all.
Question.
Okay.
The safety tabs on all these, if somebody removes them or we see them gone, should we report this?
Yep, so the question is, if somebody has snipped these tags, you'll see them on our disconnects, you'll see them on the meter housing. If somebody comes by and clips those off and you notice it, I would probably report that. That sounds to me, there's the easy thing of a kid coming by and slamming a disconnect off and running off. Snipping one of these actually requires thinking to yourself, I want to take that off and getting a tool out.
Right.
That's a higher level of vandalism than I think that, so we'd want to know about that, and we'd also prefer it if you replace them immediately.
Okay.
So these are there for the resident.
That's right.
These are there for the resident safety. We don't want them in here.
But it's okay for us to put a wire field.
It's okay if you just stick it back on there. You can put a zip tie on there. Yep. So it doesn't have to be one of these tags either. Some other things to talk about are the arrays up on the roof have wire mesh surrounding the entire perimeter. We refer to that as an animal guard. It's pretty much to keep squirrels and pigeons out from underneath the array. So squirrels in Colorado, for some reason, just love the insulation on wires, and so they'll get under there and chew that stuff off, and that's a safety issue. We've had pigeons roosting under there. We've had all kinds of animal damage. So that's there to keep those animals out. If you're up there doing any routine maintenance and you bump it with your foot and maybe offset it a little bit, we would prefer you let us know that rather than not, because if that thing fails for any reason, then animals are going to get under there and set up shop. It's easy for us to fix. It's no big deal. If you see that for some reason it was installed incorrectly and it's failing, or if there's a section missing, again, 668 of these arrays. We try to do a great job. We really are happy with our quality of work. However, at that volume, there are going to be some things that get missed. So just let us know about it. We'll come out and fix it. We'd rather do that than have animals set up shop under there. Question came up earlier today about leaves collecting on the upper side of the array. I would say if you're up there doing gutters, if you wouldn't mind just blowing the leaves out of there, that would be helpful as well. If there is a big buildup, on the bottom edge of the array, from leaves coming from the top and collecting down on the bottom. If it gets too bad or if it's holding moisture, we'll come out and take that off and clean out under there,
Use a blower or a broom?
You could use a blower. I would prefer not using a broom under there. The backs of the modules are very sensitive. They're not glass encased, so they can be damaged. So if you were to get under there with a broom and whack the underside of it, you could damage that module. I'd prefer you guys don't do that. But yeah, blowing it out should be just fine. I think wasp nests are probably, I would say they're no more likely under our arrays than they are under an eave or something like that. They're not going to hurt the arrays. They're definitely an issue for residents and maintenance staff, but
Spray them, we're not gonna hurt them.
if you spray them, again, the modules, just like these boxes, are designed to live outside. They're designed to, they're pretty resistant. So if you spray it with some sort of wasp killer, it's probably not going to hurt the array. So. Any other things that I've missed, guys, from my last couple? So the question is, can I or Infinity or anyone monitor this site remotely? The most granular data we have is that Xcel Energy produces a bill each month that shows the reading from the PV production meter and the reading of the net meter. So that's the only level of detail that anybody has off-site. So we don't expect you guys, and so depending on how those numbers look compared with the previous month, we can tell if it's been off for a significant amount of time. Now there are seasonal variations in production and things like that, so that all gets taken into account. But you guys are really the eyes and the ears on the ground. And if you guys see something, especially if you see something that's happening repeatedly, that's the best information we have to make sure that the overall system is working. I would say I would say anytime you're up on the roof, it's probably best practice to turn it down for, if you're only up there for an hour or so. You don't necessarily have to, but best practice to do so.
And it's okay to hose off the array too while you go up there hosing out the gutter.
The array itself.
Bird crap or whatever.
Right.
What we've done is part of what we've done for Infinity is we've built production models, and we know how much these are going to produce. We take into account cloudy days. We take into account soiling, things like that. But if it's beneficial for everybody if while you guys are up there cleaning those modules off, just makes them produce more. One common question you guys will have from the residents is, now that I have solar, what if it snows? What happens if it snows? So the answer to the residents is that even in this situation where the solar is producing nothing, the resident is still connected to the grid, and now they're getting 100% of their power from the grid. All the solar is doing when it's in operation is offsetting how much you're buying from Xcel. So if somebody comes and turns it off, if it's snowy for a week and the panels don't have any sun on them, the resident won't notice any difference in their electrical service. So that's a critical piece that folks who aren't as familiar with solar get concerned about. Is, great, I've got solar, what if it doesn't work anymore? If it doesn't work, you're still covered by the grid. Question was whether or not you have to worry about shoveling the panels off or excessive amount of buildup on the snow. The nice thing about solar panels is that they're oriented toward the sun. The nice thing about Colorado is that it's very rarely overcast. Even if it snows one day, usually by the afternoon the sun's coming out and it's melting that stuff off. So the panels will get really hot, so bear that in mind. If you're up on a roof in the summertime and you go to put your hand down to steady yourself or something, they're going to be pretty hot. So that also works in our favor when it snows. That snow will melt off pretty quickly. While we're on the subject of being up on the roof, we have installed roof anchors, at least 2 per roof, usually more, that fold over the ridge, and they're underneath the ridge cap. We left all of our anchors there on site. We left them there for our guys to use when they come back to service. Those are lagged into the underlying roof structure. They're super solid. you guys are welcome to tie into those if you're up on the roof from a safety perspective as well. So those are all, yep, you can see one right there. So if we need to get up there for any reason, our guys are going to be tying into those, and you guys are welcome to use those as well.
We're going to go do some gutters. All we have to do is just turn off that box, right?
That's it.
All
All you have to do is turn it off while you're up there doing gutters. So I would say if you have a particularly challenging resident that's just destroying things in their unit, and you got to go out there all the time and fix lights and fix outlets and whatever. If this system is, if you're turning it off more than say a couple times a month, I would say probably Jordan wants to know, but probably routine stuff isn't that big of a deal. Yeah. So we're looking at really macro level numbers for a lot of these systems. So being off for a little while you do your gutters. I mean, how long does it take you to do the gutters? Maybe an hour, half an hour. It's probably not really gonna be that big of a deal. So
One thing that's interesting about this system here is something's missing on this wall. And it's like they removed coax or something, but that's you have to put your eyes to missing items. It could well be that ground. Oh yeah, I got
so what Dan is pointing out here, and I'll actually tell you what's missing here. It's our ground wire that we installed.
Okay.
So when you walk up to site, so you see our ground wire moving this way across the wall. Originally, when we installed it, it followed this path. And before we got to turn it on, somebody came and snipped all that copper out of here. This is a great example. So we have a lot of exposed copper on these systems. It's important, if you guys notice that as well, let somebody know about it. You know, for example, now that somebody's stolen this once, I wouldn't be surprised if this is going to disappear. The system will operate without it. It'll operate for the most part safely without it. It's still part of the design system and we want it to be there. So let us know if you know, it's great you brought that up, Dan, because you can see there was something that was here.
Oh yeah.
And somebody came and removed it.
went all the way down the
So if that is missing, we do not have to turn the unit off. We can leave it on, or should we make it a practice to turn that off and immediately notify somebody?
So the question is, if they notice this missing, should they turn it off? They turn it off, make a phone call. That's the sort of thing that we need to know about sooner than later as well. So, you know, we haven't anticipated seeing that a big deal out here in the dispersed places like North Lincoln and Columbine, where there's lots of folks running around and there's lots of copper. That could potentially be an issue. So one of the other things that we've encouraged guys to do is, I know sometimes you guys will transfer between developments and you may end up at North Lincoln. Every single system has a DC and an AC disconnect right at the inverter. That's a constant. One thing to check in with your new maintenance supervisor is actually how we're doing the interconnection. So like I said, at Quig Newton, there's actual breakers inside the units. At all the dispersed, we're typically doing taps either inside or outside. At Columbine, we're tapping, but we're tapping in a different location. So maybe just check in with your maintenance supervisor about that. But regardless, these are always there and you should always turn those off. Eventually it'll, you know, it may be best practice to start from the AC side, because again, the inverter needs that grid voltage to function. So if you hit it with the AC first, it'll start waking up, and then you hit it with the DC, but ultimately it doesn't matter. When you walk up to it and it's reading error, it's important to make sure that both switches are in the on position. Now that includes the switch on the inside. If there's one on the inside, you want to check that as well. If all three in that case, the two AC disconnects and the DC disconnect are on and it's reading an error code, go ahead and jot that down and communicate upstream. If it's reading an error code and one of the switches off, turn the switch back on and then see if it normalizes after about 3 to 5 minutes. If it kicks back on and everything's fine, then that's what we want. That's what we're looking for. We're looking for the solid green light to be on whenever the sun is out. The question was to talk about these 2 meters. I sort of touched on it already. This is a PV production meter. This is a piece of equipment that we added as a part of our installation. You can notice because it says PV production meter right there. So the way electricity is bought and sold from the utility or from Infinity is in a kilowatt hour. So our system produces watts in an instantaneous method, I guess. Watts are produced instantaneously. So if this box is producing 1,000 watts and it stays that way for 1 hour, that is 1,000 watt hour or 1 kilowatt hour. And that's how energy is bought and sold, is in kilowatt hours. Typically in Colorado, they're about 10 cents a kilowatt hour. So this PV production meter started at 0, and every day that the system produces, it tabulates how many kilowatt hours the inverter has produced. So right now, we've produced 1,220 kilowatt hours since we turned that on. So it just goes up and up and up forever. It's cumulative. And the way you can see how much this system has produced in, say, a month is if you come out here on September 1st, it'll give you a number. If you come back on October 1st, it gives you a bigger number, and you subtract the 2, and that gives you how much it's produced in that time period. So that's cumulative. It's all PV. Now, what we've also done, or what Excel has done, is previously there was a different meter in this housing. When we turned the system on, Excel came out and installed what's called a net meter. So the net meter has the ability to determine how much energy has been purchased from the grid over a given amount of time. So right now, this net meter is reading 99,900. So the interesting thing about these meters is they start at 0 also. Let's say there was no solar being produced. Over time, you continually buy energy from Excel. That number goes up and up and up and up. So if you bought 100 kilowatt hours in a month, it would read 100. What it's doing right now is actually doing the calculation of how much energy above the solar the home has consumed. And when it rolls backwards into the 9s, it works like a car odometer. So it goes from 0 into the 99,990. So what we're seeing here is that the solar has outpaced consumption since we turned it on at this unit. So there's excess power that the solar is generating that's being fed back onto the grid, and Excel keeps track of that. They build a bank for this unit. So what we typically see is during the day, so in the morning, the family wakes up and starts consuming electricity. Maybe there's not very much solar being produced. They leave for the day. All the consumption goes down. All the TVs get turned off, all the lights get turned off, they leave. Sun comes out, solar produces. So you're rolling the meter backwards in that case, you're overproducing. Then at the end of the day, the family comes home, they start making dinner, they turn the TVs on, the sun goes down. All of a sudden the consumption goes up, but the production goes down. And so the net meter keeps track of those varying, how much it's using versus how much it's producing. So the really neat thing about this unit is that since we turned it on, the solar has produced more than the home has consumed. So when you see it read in the 99s like that, it's rolled backwards from 0. The number on there is how much they're saving, not necessarily. What the net does is it looks at how much has been consumed versus how much has been produced, and it gives you the net calculation there. So that's just PV production. That doesn't take into account consumption and lights and TVs and stuff. This takes into account lights and TVs and stuff minus the solar. So that's how the net metering sort of situation works on these systems. And so Infinity gets a readout from Excel, the net meter reading plus the PV production meter reading, and you can back out consumption from those calculations.
How long does it take for the system to pay for itself?
So the question is, how long does it take for the system to pay for itself? Ultimately, from DHA's perspective, DHA didn't purchase any of this equipment. DHA has not outlaid very much cash for these systems. So DHA is almost realizing a benefit instantaneously by paying lower bills. Payback would be something that Infinity is concerned about because they purchased all this equipment, they paid us to install it, but they get payments from DHA each month. They act like a utility. They also get federal and state level tax incentives. So their payback is sort of calculated by that. But the nice thing about DHA is, again, since you guys didn't have to buy all this stuff, you didn't pay us to install it, you're not out very much. All you're doing is sort of leasing your roof space and asking basically the maintenance staff to keep an eye on it. Yeah, you locked in your power rate for any kilowatt hour that's produced by one of these inverters is at a fixed rate for the next 20 years, which is a great thing for DHA to know. Basically, you're locking in some of your operating costs. You know how much that's going to be over time. So this is actually, so the question was, how is the system grounded? So each one of these systems, both the inverter and the AC disconnect, are grounded back to the original ground rod. This is a grounding electrode conductor, which is a conductor that connects the system to the grounding electrode. There's also an equipment grounding conductor, which is run through all the conduits and everything. But again, the grounding electrode conductor is a much more direct path to ground. So if that's missing, we do need to replace it. What if I come on site and I see the array is damaged for some reason? Either some kid threw a baseball bat up there, or there's a branch that came off one of the trees and landed on it's damaged the array in one form or another. Just walk over, turn these off, and make a phone call. Now the deal there is that if the panel itself is broken and the sun is out, that is a dangerous situation for you. You don't want to be anywhere near that array because, again, the panel itself is energized, it will be creating electricity, and the seal, I guess, that protects you is now broken, right? The glass is broken, there's things contacting each other that shouldn't. So that is an immediate phone call, immediate up the chain to get somebody out here to take a look at it. So,
You
but
guys gonna have people come around and check these things every once in a while too, except for us?
we are again in our operations and maintenance contract with Infinity. I'll let Jordan talk to that, but I don't believe we have a routine maintenance check. But we do a whole bunch of things. If you notice something and you call us out, we don't just come and just flip the switch and walk away. We do a whole preventative maintenance thing while we're on site. I would say scrap metal could potentially be a very dangerous situation because it's conductive. It's different than a baseball bat or a rock. If you see it up there, there's a couple of different things. If it hasn't damaged the array, there's probably no big issue. But if it's sticking out of a pile of broken glass, that's what we want to know about. The modules are pretty resilient. You can throw, let's say, a football or kick a soccer ball up there. It's not going to hurt them at all. It would be hard to get something under the panels because we have that animal guard there.
They wrap all the way around?
They wrap all the way around, exactly. So, if it's something conductive, I would eyeball that a little more suspiciously than I would like somebody's shoe or a Frisbee or something. I would say if there's a shoe or something on the array, it sort of depends on the configuration of the array. So if there's one row of panels and it's sitting right in the middle of one of those things and you can get up on the roof and sort of knock it off, that's no big deal. If there's a big rectangle, say of 4 rows, and it's right in the middle, I would prefer you not walk on the array to get out there and move it off. I'd prefer you not to try and knock it off with something long. That's the sort of thing, it's sort of a judgment call sort of a thing. We want to empower you guys to do routine things without damage. We don't want you to damage the equipment either. I've also met with Shad and I've talked to him about specific, if they need to replace this box, that's a level of service that we need to know about, and I want to make sure he reconnects everything properly, and so that conversation sort of happens separately as well. Yes, if you notice there's something that doesn't look quite right, make a note of it and take the steps toward getting it fixed as soon as possible. Because if the breaker needs to be changed, you should turn this off and turn the main breaker for the unit off. That way you're working on a de-energized panel. Are we worried about leaves and things getting into these fins? It hasn't really been an issue. They'll have a tendency to clear right all the way through. I think that, the Namaste Solar, I didn't really mention, but Namaste Solar, we're the largest local Colorado solar installer. We've got 2,500 installations under our belt. For the most part, this equipment has a tendency to take care of itself. We don't see a whole lot of stuff like that. The industry has designed it in such a way. I would say something like leaf accumulation is something to keep an eye on, especially in the fall. Knock it off. Just do basic stuff.
To take the leaf blower and blow. Yeah.
No, you're going to have a hard time hurting that box unless you hang on it or hit it with something. For the most part, spraying it, hitting it with the air hose isn't going to really damage it at all. If you sit there and hold it on there for a little while, eventually something might happen. But for the most part, it's pretty durable. So, yeah, make sure there's not a beehive in there if you hit it with it.
That'd be perfect for beehive.
These are heat sinks. These are heat sinks. So this is how the inverter uses it to passively cool itself. So bees probably aren't going to set up shop in there just because of the heat that's generated right there. Not so much that it's going to start a fire if some leaves get in there, but it definitely gets warm, and bees probably aren't going to be too psyched about that. So
Vegetation, I guess, is something we probably should keep an eye on too.
Yep, I think if you guys, it seems like as I've done my site evaluations and things, it seems like a lot of these sort of trash trees that have a tendency to grow up around the foundation, if you see something starting to get into the area, I'd go ahead and knock it back a little bit. That's just part of routine maintenance. The question is, if somebody gets in here and starts, a lot of these are knockouts that are pre-knocked holes that we can run conduit into. A lot of them are access into like a USB port or anything. You guys would know better than I would. My experience has been after working in solar for 5 years, we typically don't see people messing with the equipment to the level that you need a tool. So for example, anybody with a star bit can get in there and open that out. Most people aren't going to go to that level to mess with it. So yes, if you have a flathead screwdriver, you can stick it in there and unscrew it. Definitely something to keep an eye out for. And if there's one of those missing, we need to know about that. That'll affect how the system operates. You guys again know better than I do. You guys know your neighborhoods better than I do. That seems like a little excessive vandalism to me. But we're not really looking for you guys to make fixes to these things. We're just looking for you just to keep an eye on it. That's really about the extent of it. The panels do not produce heat per se. Anytime you run electrical current through anything conductive, there is some heat generated. They will collect heat. They're metal objects that are sitting in the direct sunlight, so they'll get pretty hot. They'll generate heat in the same way that the wires that are run through the wall of this house generate heat when you run current through them, but it's not something that needs to be considered. The arrays themselves are not sitting directly on the roof. They're up about 6 inches off the roof. That's for a couple different reasons. The first of all is that electronics, like a DVD player, if you take it and you stick it up on the roof, it's not going to work very well. Solar panels actually work less well the hotter they get. So the nice thing about Colorado is we have a lot of these cool, bright mornings. That's when we see the best solar production, because as soon as the heat gets to it and it starts to heat up, it starts to derate a little bit. So, but what the panels are doing is insulating the roof surface from that heat. And then we also have them lifted up off the roof to allow for passive cooling to get under there and cool them off and keep them as cool as possible. So for the most part, other than the penetrations we made. So again, you know, we do a really good job of flashing and sealing all of our attachment points. That being said, with 668 systems, it's not outside of the realm of possibility that we did a bad job on one of them. So if you guys start to see roof leaks, you know, and it looks like it's in the area of the array, let us know. That's covered under our warranty. Now, if there's a roof leak 40 feet away from the array, there's a good chance that that's not my fault. So keep that in mind as well. But if there's a roof leak that's underneath the array, we're happy to come out and take a look at it. Solar panel won't really burn out. Basically, the way they're designed and the way they're warranted is they're warranted to degrade at 1% of nameplate rating per year. Yes, so so for example, not each unit has its own box, but each system has its own box. So for example, we're standing in front of a duplex. There's 2 units here. There's only 1 system here. So again, that gets into the residents asking you, well, how come they get it but I don't? And the way we did the design was we looked at the roof, we figured out how many panels we could fit on the roof, and we designed these systems to produce over the course of a year less than 90% of the previous year's consumption. So we looked at the consumption levels for these 2 units. We'd rather install 1 system than 2, and we put the largest system we could fit into 1 unit because there isn't enough room on the roof for panels for a second unit. So that's oftentimes how we went through and did our design. Each of these designs are custom to the building based off of how many panels we can get up there and what the consumption levels for the units were. So at a place like Quig Newton, where there's 6 units in one of those buildings, typically there's only 3 solar systems on there. Does that make sense? Okay. That's a common question you guys will ask though, is when do I get mine? Say again?
Why don't I have electricity when this?
Why don't I have electricity when the power goes out? How come they get when I don't? Those are very common questions that you guys will get used to answering. Yeah. Yep, exactly. So again, the power goes out, solar goes out too.